Okay, so this problem is on lecture number 5, which is the space air conditioning. So you can see that in this problem, we have a CAV system. So this is called a constant air volume system. So in this system, the airflow rate of the HVAC system is constant. So it's used to control the room air at a temperature of 20 degrees. So the room temperature is 20 degrees and the relative humidity is 50%. So outdoor air temperature and relative humidity is also given. So you can see that the value is 5 degrees and 20%. So the return air first mixes with the fresh air, and the mass flow ratio is given here. And then in the air handling unit, we have a heating coil followed by a steam humidifier. And the total air mass of the flow rate is given as 1 kilogram per second. And the supply air temperature is 30%, and relative humidity is 40%. And you are supposed to find the temperature and the relative humidity of the air entering the heating coil, and also a heat transfer rate at the heating coil, and at last the mass flow rate of the water vapor added to the air by the humidifier. So in order to solve this problem, first we will draw a simple schematic here. So in this problem, obviously it's a CAV system, and we have fresh air uh, as illustrated here. So in this room, so this is the room, and we have return air and supply air. So the return air part of it will be exhausted, and the remaining part of the return air will be supplied back to the air handling unit. And also we have fresh air coming. So this is the exhaust, and we have fresh air here coming in. So this is the return duct. And after the return air mixes with the fresh air, and the mass flow ratio is 4:1. So if the total air mass flow rate is 1 kilogram per second, then the return air is 0.8 kilogram per second, and fresh air is 0.2 kilogram per second. So that's the mass flow rate of the return air and fresh air. So when the return air mixes with the fresh air, it will go through a heating coil at first. So we have a heating coil here, and then followed by a steam humidifier. So humidifier. And after the humidifier, the air will be supplied back to the space here. And so we have supply air here and return air here. So we know that the room temperature is 20 degrees and the relative humidity is 50%. So we will define this state as state 1. So we have return air state 1. And then This is also return air, state 1, because this is return air. And fresh air, we define fresh air as state 2. And for fresh air, it's obviously the outdoor air temperature. So for state 1, we know that it's 20 degrees and 50%. And for state 2, we know that from the problem statement, outdoor air is 5 degrees and sorry, and 20%. And then the third state is the state of air before the heating coil. So it's the mixture of state 1 and state 2. So we have state 3. State 3 can be easily obtained because we already know the mass flow ratio of state 1 and state 2. And after the heating coil, we have state 4. And what do we know about state 4? Currently, we don't know anything about state 4. But we know that from state 3 to state 4, it's sensible heating process because it goes through a heating coil. So that means the temperature will rise. Sensible heating process. That means the temperature will rise, but the humidity ratio will remain the same. And for state 5 is the supply air, and we know from our problem statement that is supply air temperature 30 degrees, relative humidity 40%. So for state 5, we know that the temperature is 30 degrees and relative humidity is 40%. So first of all, we will need to know the temperature and the relative humidity of the air entering the heating coil, which means state 3. So in the first problem, we will need to find state 3. So in order to find state 3, what we do is we can find it on the psychrometric chart. So first of all, I'm going to briefly show how the process looks like on the psychrometric chart. So this is this line is the saturation line here, and we have temperature and humidity ratio. So say 1 is 20 degrees 50%. So we assume this is state 1, and state 2 will be somewhere here. So once you are given with a psychrometric chart, you can easily locate these two states as the two independent parameters are already given. And then what you do is you connect these two dots, and since the mass flow rate ratio is 4:1, so it will be somewhere here. So this will be say 3, and the length of the line 2 to 3 is 4 times the length of the line from 3 to 1. So this is how you can locate state 3. And for state 3, from the psychrometric charts, we will find that the temperature is about 17 degrees, and the relative humidity is 50%. So this is for the first problem. So now you can either go to the online psychrometric chart to execute this calculation process, or you can take out the psychrometric chart on paper and follow the illustrations here and complete the progress by yourself. So that is the first question. So the second question we have the heat transfer rate at the heating coil. So in order to find the heat transfer rate at the heating coil, we will need to do we will need to find out the state of the air before it enters the heating coil and after or at the outlet of the heating coil. So for the inlet state 3, we have already figured that out. So we have already located that. And for state 4, what we do know is that from state 3 to state 4, the humidity ratio will remain the same. So it will be somewhere like this. So how you can locate state 4 when it follows this constant humidity ratio line? That is how state 5 comes into the picture. So we do know that state 5 is 30 degrees and 40%, and we know that from state 4 to state 5, it goes through a steam humidifier. So when the moist air goes through steam humidifier, we know that, temperature 4 is actually approximate to temperature at state 5 because it goes through the steam humidifier. So from state 5, we know that it's 30 degrees and 40%. So temperature at state 4 is 30%. 30 degrees. So this is how we can locate state number 4. We just draw a line from state number 3 and follow this constant humidity ratio line. And state number 5 will be somewhere here. So this is how it looks like. And omega 4 equals omega 3 as from state 4 to state 5, from state 3 to state 4, the air goes through a heating coil. So omega 3, state 3 is already located, and T3 is 17 degrees, and the relative humidity at state 3 is 50%. So omega 3 will be 0.006 kilogram per kilogram dry air. So this is how you can locate state 3 and state 4. And for the heat transfer rate at the heating coil, what we do is we apply the energy balance. So for the energy balance, we know that the heat transfer rate will be mass of air times H4 minus H3. So since we have already located state 4 and state 4 and state 3, so we can directly read the corresponding values of H4 and H3. And for the mass flow rate of air, since it's constant air volume system, CAV system, so the total air mass flow rate is 1 kilogram per second. So we have this mass of air is 1 kilogram per second. And from the psychrometric charts, H4 is 45.5 kilojoules per kilogram dry air. And H3 also from psychrometric chart. H3 is 32.5 kilojoules per kilogram dry air. So you plug in the numbers and you will find that the value is 13 kilowatts. So that's for the second problem. So the third problem is you're supposed to find the mass flow rates of water vapor added to the air by the humidifier. So in order to do that, we will need to apply mass balance. So this is energy balance. So this is problem number 1, problem number 2. For problem number 3, you will need to apply mass balance. So for mass balance, you apply the mass balance during this process. During for the process when the moist air goes through the steam humidifier. So we have 2 inlets and 1 outlet. We do the energy balance for the water. So we have the first inlet of water is the water vapor accompanying the inlet airstream. So we have the mass flow rate of the water vapor of the incoming water vapor to be omega 4, which is the humidity ratio, times the mass of air. So that's the first stream. The second stream is the water vapor added to the air by the humidifier, which is what we need to calculate. And the outlet, so this is the 2 inlets, and 1 outlet is the mass flow rate of the water vapor accompanying the outlet air. So we have mass flow rate of air times omega 4 plus mass of water vapor added to the air by the humidifier equals the mass flow rate of air times the humidity ratio at state 5, which is omega 5. So 1 inlet plus mass of water vapor equals 1 outlet. So all the states can also be found from the psychrometric chart. So first of all, for omega 4, it's equal to omega 3, and it's 0.006 kilogram per kilogram dry air. And for state 5, for omega 5, so for state 5, we also from the statement, the 2 independent parameters have already been given. So we can go to the psychrometric chart and find the corresponding humidity ratio to 30 degrees and 40%. So and then omega 5 is about 0.0106 kilogram per kilogram dry air. So you can see that from this equation, this is 1 kilogram per second, so it's a known value, and omega 4 is 0.006 kilogram per kilogram dry air, and this is what we need to calculate. And mass of air is also a known value, and omega 5 is 0.0106 kilogram per kilogram dry air. So the mass flow rate of the water vapor is calculated to be 0.0046 kilogram per second. So that is all for the illustration and the solution of tutorial number 5. So the key points here for this problem is, first of all, you will need to transform the description. So you can see that the description is quite long to this schematic here. So once you can, if you can draw out the schematic, you can clearly define. You can see that all the states here, state 1, 2, 3, 4, 5. And then the second key point is you will need to understand how to use the psychrometric chart. So sometimes in exam questions, exam problems, you will be given with a, so this is just a arbitrary psychrometric chart, but in exam questions, sometimes you will be given with a psychrometric chart, and you will be asked to show the process, the air conditioning process on the psychrometric chart. So this is the second key point of this problem. And the third key point is how you can actually read the psychrometric chart. As you can see here, starting from the first question, find the temperature and the relative humidity of the air entering the heating coil. From here, this is where we first will use the psychrometric chart. So once you can read the psychrometric chart, you will be able to read the temperature, relative humidity, and also the humidity ratio of state 3, and it will be used in in question number 2 and question number 3 also. And at last, one thing that is very important is we can see that in the problem description, I will only state the equipment or devices such as heating coil and steam humidifier. However, you will need to understand how the air conditioning process looks like. For example, when you see heating coil, you will know that that means from before the coil and after the coil, the air goes through a sensible heating process. And for the sensible heating process, the temperature will rise and the humidity ratio value will remain the same. And also for steam humidifier, you will know that the temperature will remain the same during the process, more or less, and only the humidity ratio will increase. So if we change this steam humidifier to humidifier with water injection, then that's another story. So this is related to lecture number 2 also. So also in our exam questions, especially for this kind of long calculation questions, it will be related to multiple lecture notes. So make sure you understand how the process looks like, how the air conditioning process looks like, and how you will need to calculate and solve the problem. So this is all for problem number 1, and I'm not going to illustrate how you can locate the air state on the psychrometric chart, or how you can find its corresponding values. And it's highly recommended that you solve it by yourself and see if you can get similar results here. So you don't need to get a 100% so-called accurate results, because when you read the psychrometric chart, there will be error. Okay, so I will upload the solutions to tutorial number 5, and I'm going to stop recording now.